Hi everyone, so we're going to work on graphing today, and this is the chart that you need to work on memorizing the part that I have highlighted. So you want to know the trig functions in the first quadrant here. You want to know on the quadrantals, 180 or pi, 270, 3 pi over 2, 360 or 2 pi, which is the same as this 0 degrees right here. So make sure you have these memorized. You have example 1 done from past notes, but looking at what is the graph of y equals tangent x. So the tangent of 0 is 0. So you've got this point right here in the middle. And then the tangent of pi over 4 is 1. And so that's, if you're here at pi over 4, you'd be up 1. And then the tangent of pi over 2 is undefined. So this is your asymptote. And at negative pi over 2, it would also be undefined. And then this would be down here at negative 1. And so here's what your tangent graph looks like. The period of a tangent graph, where it starts and ends, is every pi units. So it has pi units for the period. This asymptote's at negative pi over 2, and this one's at positive pi over 2. So the domain is going to be all real numbers, except for x cannot equal pi over 2 plus k pi. The range goes low and high forever from negative infinity to infinity. The x-intercept is at 0, plus that happens every pi units, so every k pi, comma 0. So you get another one of these here. Here's your asymptote again, and your graph's going to hit at 1 here and here. So here's another period of that graph. Increasing, decreasing, this graph is always increasing. It has a period of pi, and it has vertical asymptotes at x equals pi over 2 plus k pi. Now we're going to graph the cotangent graph, and the cotangent graph is the reciprocal of the tangent. So where tangent is 0, if you take the reciprocal of 0, think of it as 0 over 1. The reciprocal is 1 over 0, which is undefined. So where the tangent graph at 0, it equals 0, here it's going to be undefined, and at pi, it's also going to be undefined. And then here at pi over 2, the cotangent graph is going to be 0. At pi over 4, we're up here at 1, and then we're down here at negative 1. So here is the cotangent graph, and it's moving in that opposite direction, and it's also shifted by a half pi. So this is what the cotangent graph. Now it is similar to the tangent in that the period is still pi units. So every pi units, we get this same graph. So if I wanted to graph another period over here, I would put an asymptote at negative pi. At negative pi over 2, it's 0. And then here we'd be at 1, and here we'd be at negative 1. And so you would get this graph right here. So the domain, we're looking at the domain as being all real numbers again, except for where we have those asymptotes. So except for where x cannot equal pi over, so this is pi, or you could even do 0 plus k pi. That might even look better than pi plus k pi. So it doesn't really matter, but I would do 0 plus k pi. The range is going to go negative infinity to infinity. This graph is always decreasing, and it has vertical asymptotes at x equals 0 plus k pi. Now where the cosine is equal to 0, this graph is at 0. And where the sine is equal to 0, because sine is in the denominator, you're going to get undefined. So where the sine graph is 0, it's undefined in the cotangent. We're going to look at the secant graph, and if you recall, secant goes with cosine. Remember, those are reciprocals of each other. So how you're going to graph the secant graph is you're going to start by sketching the cosine graph. So you would take your cosine graph, and you remember the cosine starts up here at 1, and then it goes 5 points, down, down, up, up. And I always think of it as a skateboard ramp. So at pi over 2, it's at 0. At pi, it's at -1. At 3 pi over 2, it's at 0. And then at 2 pi, it's back up here at 1. And so I'm going to just draw a dotted line since this isn't the graph that I'm actually sketching. I'm going to sketch secant graph. And let's go ahead. That's one period, goes from 0 to 2 pi, and then the graph just keeps repeating. And I'm going to go ahead and graph another period of this graph. So it's 5 points. It goes down, down, back up, up. And here's your cosine graph. So now the secant graph, how you're going to graph the secant graph is you always start by graphing the asymptotes. And if you take 0 and you flip it, you get undefined. So where this is 0 is where you're going to have asymptotes. So let's draw asymptotes like this. So here's your asymptotes. And the graph, the secant graph, is not going to hit those asymptotes. And then to graph this, you're just taking each piece in between the asymptotes and you're basically flipping it. So here, if I said, what is the secant of 0? You would say it's 1, because when you flip 1, you get 1. But now all of these values, when you take the reciprocal, are going to move in this other direction. And so you're going to get that piece right there. And then down here, what is the reciprocal of -1? It's still -1. So you get that value. And then all of these values, when you flip them for the reciprocal, are going to move in that downward direction. And then this part here, you're going to start here at 1. When you take the reciprocal of 1, you get 1. And then you get that piece here. The reciprocal of -1 is -1. And then this piece right here is going to go right here. So this is what the secant graph looks like. One period of the secant graph, you could think of it as this piece, and then that piece, and then this piece right there. So that's one period that just keeps repeating over and over and over again. All right, every 2 pi units. So let's go through and list the characteristics. The domain, well, you can see that the domain is all real numbers except for where we have these asymptotes. So it's going to go from -infinity to infinity. This is just the easiest way to write it. -infinity to infinity. However, x cannot equal. Pick any asymptote. So let's start with pi over 2 and say pi over 2 plus k pi. The range, it starts at -1 and goes down to infinity. So the range, and I guess I need a bracket there, not a parenthesis. Fix. All right, so the range goes from -1 to -infinity, but that's wrong because we need to go from low to high. Oh, goodness. All right, last time, let's get this right. -infinity. No, this is a parenthesis. I really should just stop and erase this, but I'm going to leave it. All right, so -infinity to -1 bracket. Yay, I got it. And then we're going to start at 1 bracket and go to infinity, parenthesis. There's only one intercept. It's the y-intercept, and there's a y-intercept right up here, and that intercept is at 0, up 1. The period, it repeats just like the cosine graph every 2 pi units. The local max is going to be the top of these hills. So the local max is going to be at 1, and you can just write 1. And the local min is at -1. And again, these are local, not the absolute. The arrows going up forever and down forever are the absolute extrema. Okay, and vertical asymptotes would be x equals pi over 2 plus k pi. Yay! All right, so since secant loves cosine, we know that cosecant loves sine. So I bet you could figure out the cosecant graph doing just what we did with the secant graph. It's going to be the same thing. And we're remembering that sine loves cosecant. So when we draw the cosecant graph, we start with the sine graph. So the sine graph, I really love it. Starts in the middle at 0, 0. It goes up and over, down and under. So here we go, up and over, down and under. This has a period of 2 pi. I can start it over here and do the same thing, up, down, down, up and over, down and under. And the sine graph always starts in the middle at 0, 0. Now, to do the cosecant graph, everywhere we hit the zeros, when we flip 0, we get undefined. So asymptotes, everywhere this graph hits 0, we are undefined. Now the reciprocal of 1 is simply going to be 1. So this point is on the graph, and then the reciprocal of all these other points are going to flip. And so here, same thing, and then this flips in this direction. So there's one period of the cosecant graph. You get a U and you get a hill. So, or a dip and a hill. All right, and then the dips and the hills just keep going. So here, that's going to be 1, and then everything flips. And you're not supposed to ever touch your asymptote, just approach it. So don't be as messy as me. And there you go. So looking at the domain, we're going to go all real numbers except for what x can't equal. And x can't be where these asymptotes are. So 0 plus k pi. The range, we're going to get it right this time. It's going to start at -infinity, and it's going to stop at -1, and then union, and it's going to pick up at +1, and it's going to go up to infinity. The intercepts, there are not any intercepts, so none. There's no x or y intercepts. The local max is 1 again, the local min is -1, the period is 2 pi, and the vertical asymptote is x equals for a vertical line, and I could say 0 plus k pi. So here, and my camera is kind of crooked. Okay, so here we go on this. Instead of graphing secant, we're going to graph y equals 1 plus 2 cosine x. And then after you graph the cosine, you just change it to the secant. Flip, 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 and you've got the secant. So super easy. So we know that the +1 is going to shift this whole graph up 1. So what I like to do is, let's say that this is 1. And so I'm going to make this the new center of the graph. And cosine always starts 1 above. So this is where the cosine would start. But the amplitude is 2. So from that center, it's going to stretch up. So here's 1, 2, 3. It's going to stretch up to 3, and down 0, 1, 2. So down to -1. So the cosine graph is actually going to start up here at 3, and then it's going to go to the middle, and then it's going to go down to -1, back to the middle, and then up to 3. So this graph is going to go down, down, up, up. And we could repeat this graph if we wanted over here, and then we go middle, and then we would go to -1, and then we would come to the middle, and then back up to 3. So the graph goes down, down, up, up. All right, so there is my cosine graph, and now I'm ready to do the secant. So when you are drawing your asymptotes, you're going to draw your asymptotes through these points in the middle. So this is where those asymptotes go, through those points in your new center, because the whole graph got shifted up. All right, and then it's just a matter of flipping everything. So I'm going to take this and flip it. I'm going to take this piece here and flip it. I'm going to take this piece in the middle and flip it. So we have this U in the center, united. And then down here, we're going to take this and we're going to flip it. And up here, we can flip that piece there. So I just graphed 2 periods of this graph. And this is the 1 + 2 secant. Now, your graph really does kind of turn into a mess. So I think a highlighter is pretty nice. Here's a blue highlighter. And I can highlight in blue my actual solution. And those are not, I'm not hitting the graph very well, but you've got the point. I'm going to take the tangent graph and I'm going to flip that graph because of the negative. So it's going to go in the same direction as the cotangent graph. And then I'm also going to change the period. So you guys, I just want to remind you about the period. The period of tangent is usually pi units. But we are going to take pi and divide it by b. And you see that 2 on the bottom? That makes b 1/2. So here's your 1/2. So pi divided by 1/2. So basically, it's pi divided by 1/2 is the same thing as pi times 2, which is 2 pi. So this graph is going to repeat every 2 pi units. So if I go from the center, the tangent of 0 is 0. And then over here, this is pi, and over here, this is negative pi. And so you can see that when you take pi plus pi, you get a period of 2 pi. So this b right here is a horizontal stretch. It's stretching the graph. Now, typically the tangent graph goes up to the right, but the negative reflects it. And so now this graph, I don't need to do dotted, I can do a solid, is going to go up to the left instead. And on this side, it's going to come here and go down to the right. I kind of missed that point. There you go. So that is the graph that got reflected and got stretched horizontally. You try graph, which means you're supposed to try this one on your own. Let me help you for a moment. So instead of looking at cosecant, I'd like you to look at sine first. So this is y equals the opposite of sine. Now, inside those parentheses, you never want 2 to be in front of x. You only want a 1 there. So you factor out the 2 and you end up with x subtract pi over 2. And so looking at this graph, you're going to get all sorts of things. The negative is going to reflect the graph, which means instead of like, here's your normal graph, up and over, down and under. But when you reflect it, it's going to go down and under, up and over. So that's what the reflection does to the graph. The 2 right here is your B. And so your period is usually 2 pi, but this is going to be 2 pi over B, which is 2 pi over 2, which means now your period is going to be every pi units. You're going to get a down and under, up and over. From here to here, every pi units. All right, so that's what this 2 does here. We refer to this as B, and it changes the period. It's basically the horizontal stretch or shrink, which is also going to change your frequency, because now we're getting a down and under, up and over every pi units, which means every 2 pi units we get 2 of those. And that's why we have a 2 here. And then x subtract pi over 2 is going to be what we call a phase shift. So horizontal shifts in trig are called phase shifts. And the phase shift is going to go opposite of what you think, and it's going to go to the right by pi over 2. So stop the video and try this graph. I'll graph it as well, and then you can compare. So let me show you how this works. The first thing I would do is I would ignore the phase shift, and I would worry about the reflect, and I would worry about the period. So from 0 to pi, you're going to get a down and under, up and over. So you're going to have to break, here's the middle, and then there's the middle of that at pi over 4, and then at 3/4 pi. And so you're going to start here at 0, 0. And maybe I'll put -1 there and +1 there. And so I'm going to go down and under, up and over. So here's my graph, down and under, up and over. And that's what the graph looks like without the phase shift. And then if you're going to phase shift that, you have to move each of those points by a half pi. And so this point gets moved to the right, 1, 2. And this point gets moved to the right, 1, 2, because I'm counting by fourths. And then this point up here gets moved to the right, 1, 2. And this point, 1, 2. And so now my graph looks like this, down and under, up and over. So there's my new graph. All right, and so you can continue that in going the other direction. So if I want to go up, over, down and under. So here's my graph, and the red is my graph. So, and you can just keep continuing that pattern as many times as you want. So here, I'll just keep continuing this, and you can see over here, I kind of messed up a little bit. Could fix that. So this is here and then here. Okay, so the red is my sine graph that got phase shifted by a half pi and got reflected. And now we're not done yet because we need to put in our asymptotes. So our asymptotes are going to be here, everywhere. We hit 0. And then you're going to just begin flipping everything. Man, I've used about every color, but let's do this. Now, the blue is going to be the cosecant graph. So then I'm going to take these and flip them and flip them and flip them Flip them, and I've done a whole bunch of periods. All right, and then this is what your graph looks like, and you could highlight those blues, and that's your solution. All right, everyone, look at the reflection questions, and that's everything for graphing tangent, cotangent, secant, and cosecant. Thanks, everyone.